Hello and welcome my excellent students. In this video we'll be looking at addition in modular arithmetic. But as it is our usual practice, we'll start off by solving the take-home questions from the previous video. So the first question is to find the set of residues for A modulo 12. So like I've explained in the previous video, set of residues for any particular modulo is to start from 0 and stop at the digit that immediately precedes the modulo you are looking at. So in this case, we start from 0 and go up until 11, which is the number before 12. So modulo 12 residues will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So second question asks us to look for set of residues for modulo 16. Set of residues for modulo 16, and that would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And question 2a. Question 2a says we should reduce to its simplest form in the modulo given. Basically, first question is 107 modulo 5. So this becomes 107 divided by 5, and this would give us 21 remainder 2. So 107 in modulo 5 in the simplest form is 2. So we have business with just the remainder. For 2b, we have 63 in modulo 8. So basically this is 63 divided by 8. That will give us 7 remainder 7. 7 remainder 7. So 63 in modulo 8 is 0. And the final question, 103 modulo 13. So this is 103 divided by 13. 103 divided by 13 would give us 7 remainder 12. So to confirm that this is correct, 13 times 7 plus 12 would give us 103. So 103 in mod 13 is 12 because we have business with just the remainder. That is that on the solution to the quiz. So we move to today's video paper, which is addition in modular arithmetic. Take some examples. First example, example 1. Evaluate in the modulo indicated. Question 1. 2 plus 7 in modulo 6. Another concept that is very important in modular arithmetic that I forgot to mention is in the style of writing our addition, subtraction, and division. So instead of writing it the regular way, for addition like this, subtraction like this, multiplication like this, division like this, what we do is to have a circle around those signs. So that is what shows that this is really in modular arithmetic. So this concept is also very important. So back to our question, we have 8 plus 9 in modulo 5. We have 51 plus 43 in modulo 7. And we have 87 plus 61 in modulo 6. So let's take this one after the other before we now solve the other example. So the first one, we have 2 plus 7 modulo 6. So 2 plus 7 will give us 9. But of course, we are dealing with residues and remainders. And in modulo 6, the only possible remainders are from 0 to 5. Right? So that means 5 is not a valid modulo residue. So it cannot be our answer. So what do we do? So we do 9, which is the answer we got here in modulo 6. And basically that's 9 divided by 6, and that will give us 1 remainder, 3. And so our final answer for 2 plus 7 is 3 in modulo 6. So basically this is it. So for question B, we have 8 plus 9. 8 plus 9 will give us 17. But in modulo 5, 17 is not a valid residue because in modulo 5, the residues are 0, 1, 2, 3, 4. So we need to convert this 17 to a valid residue by doing 17 divided by 5, and that will give us 3 remainder 2. So 8 plus 9 will become 2 in modulo 5. Question C, we have 51 plus 43. 51 plus 43 will give us 94. But 94 in modulo 7 is not a valid residue because in modulo 7 the residues are 0, 1, 2, 3, 4, 5, 6. So to convert 94 to a valid mod 7, we have to do 94 divided by 7. That would give us 13 remainder 3. So therefore 51 plus 43 is actually 3 in modulo 7. For our question D, 87 plus 61 will give us 148. 148 is not a valid mod 6 residue because the residues for mod 6 is 0, 1, 2, 3, 4, 5. So to convert 148 to a valid mod 6, we have to divide by 6. So 148 divided by 6 would give us 24 remainder 4. So 87 plus 61 would actually give us 4 in modulo 6. So let's take one more example. Question 2. Prepare the addition table for modulo 6. How do we do this? You are familiar with our regular multiplication table, usually at the back of exercise book notes. So basically that's what we want to do here. The first thing when you are told to prepare a table, whether addition table, multiplication or division table, the first thing you need to know is to identify the set of possible residues in the modulo you are working with. In this case, we are working with modulo 6. Possible residues for modulo 6 is what? 0, 1, 2, 3, 4, 5. So this set of numbers or residues is what we use to prepare our table. So we create a table such as this, and then we write each of these values 0, 1, 2, 3, 4, 5. And then on this upper part we also write it 0, 1, 2, 3, 4, 5. After doing this, we draw the table properly. So we draw the table properly like this, and then put our operation here. In this case, addition, because we are dealing with addition table. And then we add each of these values one after the other. So 0 plus 0 is 0. Since 0 is a possible residue, believe it as that. 0 plus 1, 1 is a possible residue. 0 plus 2, 2, 0 plus 3, 3, 0 plus 4, 4, 0 plus 5, 5. Then we move to 1. So 1 plus 0, 1, 1 plus 2, 1 plus 1, 2, 1 plus 2, 3, 1 plus 3, 4, 1 plus 4, 5, 1 plus 6. Since 6 is not a possible residue, so we do 6 divided by the modulo. We are working with modulo 6, and that will give us one remainder 0. So it means that 6 modulo is 6 is 0. So we write 0. So 2 plus 0, 2. 2 plus 1, 3. 2 plus 2, 4. 2 plus 3, 5. 2 plus 4, 6. 6 is what? 0, because that will one remainder 0. 2 plus 5, 7. So 7 divided by 6, one remainder 1. So we write the remainder 1. 3 plus 0, 3. 3 plus 1, 4. 3 plus 2, 5. 3 plus 3, 6. So we write 0. 3 plus 4, 7. So we write the remainder here 1. 3 plus 5, 8. 8 divided by 6, one remainder 2. So we write 4 plus 0, 4. 4 plus 1, 5. 4 plus 2, 6. So 6, write 0. 4 plus 3, 7. So we write 1. 4 plus 4, 8. So we write 2. 4 plus 5, 9. 9 divided by 6, one remainder 3. So we write 3. 5 plus 0, 5. 5 plus 1, 6. So we write 0. 5 plus 2, 7. So we write 1. 5 plus 3, 8. So we write 2. 5 plus 4, 9. And because 9 over 6 is 1 remainder 3. So we write 3. And 5 plus 5, 10. And because 10 divided by 6 will give us 1 remainder 4. So we write 4. So this is our addition table for modulo 6. I hope you understand this video, and I hope you enjoyed it as much as I enjoyed explaining. Let's take the take home for today's class. Question 1. Find A 73 plus 89 in mode 8. B 3 plus 8 in mode 6. C 5 plus 11 in mode 4. Question 2. Construct addition table for modulo 4. Remember, if it didn't make sense the first time, watch it again. That is the math sense. I'll see you in the next video.